couple of comments. If you have 2 points with the same y-coordinate, that means one is horizontally across from the other, the fundamental triangle will then have a perfectly good run. The run for 3, 6 to 7, 6 would be 7 minus 3, which is 4. And the rise is 0. It doesn't go up or down. So the slope is 0 divided by 4, which is 0. Now, if one point is directly above the other, then the rise in this case would be 4, from 5 up to 9. The run from 1 to 1 is 0, so the slope would be 4 over 0, but that's undefined, so you have an undefined slope. Okay? Now, the fundamental triangle for y equals x squared, with using x values -2 and 0, is what? Well, we calculate the point on the graph for x equals -2 and for x equals 0. We know perfectly well, because we've constructed this graph, we've used these values, that when x is -2, y is 4, which means you have the point -2, 4 on the graph. So we have -2, 4. And you see that I've got at least this half of the parabola sketched here. So this is on the parabola, our y equals x squared parabola. I could have extended that over here, but I didn't want to confuse the picture any more than it already was. Okay, well, if x is 0, then of course y is 0, so we have the point 0, 0. Well, there's a point 0, 0, one of our basic points on this graph. So we have the point -2, 4, the point 0, 0. Our fundamental triangle joins this point to this point with a hypotenuse. We have a run of 2, a rise of -4, and a hypotenuse that's equal to the square root of 2 squared plus the square of -4. That'd be 4 and 16, which is 20. We can do this anytime we're given a function that we know how to evaluate, and 2 points at which we know how to evaluate that function. We can get the fundamental triangle, and this turns out to be a really very important thing, a very important object in the study of calculus and in the application of mathematics to a variety of fields.